Good afternoon, and welcome back. I don't know about you, but it seems like businesses are under a lot of pressure these days. They're getting pulled in a whole lot of different directions. They're being asked to be more innovative, to release products to market a lot more quickly, and they are also at the same time being asked to do more with less. You heard a lot about that this morning, and these types of things that AWS is trying to help our customers with addressing in the keynote this morning and probably throughout other sessions. But many of my customers that I deal with seem to think that the cloud is so far away. It's almost as if they're here down on earth and they're looking up into the sky and hearing all these wonderful promises that are being made about how the cloud can help them deal with these issues, can deliver products more quickly, how they can address their customer needs more effectively while saving money at the same time. My name is Steve Morad. I'm a solutions architect at AWS, and I help customers bridge this gap between their on-premise infrastructures and the cloud every single day. If there's one thing that I want you to take away from this message or from this session, is that the AWS cloud can be as close as you need it to be, as much as a single router hop away, or it can be as far away from you as you need it to be if your customers are on the other side of the world. So in this session, we're going to start by talking about the basic building blocks that we provide you to extend your data centers into the cloud. I'm going to give you examples of how to cost effectively and how to more effectively utilize these components, and eventually we're going to put them together into architectural patterns that you can use to extend either your data center into the cloud, or in some examples, actually taking the cloud and extending it to your customers. The very first component that we're going to talk about, upon which all the rest of these are based, is the VPC, or the Amazon Virtual Private Cloud. This is a technology and a service where we allow you to bring your own network into the cloud. You know the best about your network. You know what networks you're currently using and what your data centers and how your data centers are set up. And so you're in the best position to determine what network you want to have in the cloud, and you get to bring your own network and run it in the cloud. You can then take that network and divide it up into multiple subnets. You can divide it up however you want to, decide how you want to build those subnets and where you want to deploy network resources into those subnets. And then finally, you have the ability to create routing rules that allow you to specify how you want traffic to flow in and out of those subnets and in and out of your network. One of the things that you need to make sure that you spend a little bit of time thinking about is how you want to run your network in the cloud. As Uncle Ben said in Spider-Man, with great power comes with great responsibility, and we give you a lot of tools to very, very quickly create a network. Within just a couple of clicks, within several seconds, you can create an entire network in the cloud. You can deploy networks on the other side of the world. But there's no substitute for good planning for your network architecture. You should really think about the network that you want to build in the cloud as you would if you're planning for another data center, and the possible scalability or the possible amount of traffic or expansion that you might want to create in another data center, another set of data centers. I've had some customers who have created a really, really small network in the cloud. Maybe it supports 50 to 100 servers. They create a single subnet, and then suddenly they start wanting to expand. And just like in a regular data center, it takes some planning and movement if you need to start moving computers or devices from one network to another. So we provide you with a lot of tools to be able to very quickly create virtual private clouds, virtual private networks, and to subnet it. But there's no substitute for good planning, especially when you're dealing with networking. So once you take your subnets allow you to provide a couple of different boundaries within your virtual network in the cloud. The first thing is that it's an availability zone boundary. Availability zones allow you to provide isolation between your different network components. An availability zone each availability zone within AWS is separated with 3 unique characteristics. The first thing is that an availability zone is provided by different power suppliers. The second is that they have different access to different internet service providers. And the third thing is that they're built on different floodplains. Typically, they're within 5 to 10 miles apart. You have to get into a car and drive from one to the other, and it allows you to provide isolation from your different components and to deploy very highly available applications in the cloud. Your subnets provide a boundary, so you create a subnet and you assign that to a specific availability zone. So when you're thinking about building your networks, you want to think about your overarching network that you're going to create, as well as how you want to partition that network or create it as it relates to availability zones, so that you have enough room in your network and enough subnets to take advantage of the different availability zones or logical data centers that you would like to within your cloud environment. The second thing that subnets allow you to do is to create routing boundaries. You can create routing rules that determine what routing rules you're going to allow traffic to route in and out of your different subnets and in and out of the virtual private cloud as a whole. You can specify each subnet has the ability to associate a different set of routing rules, so you can determine which subnets you want to route to which networks. It also creates an access control boundary that allows you to determine how traffic will flow in and out of your networks and between different networks. For access control, or controlling network traffic and network flow, there are three major tools that we provide. There's security groups, network access control lists, and routing tables and routing rules. Of those three, network access control lists and routing rules are more traditional, that are protecting networks or subnets as a whole. Security groups are a much more innovative technology that we've brought to the cloud that allows you to create specific sets of rules around specific assets. So you no longer have to worry about protecting individual network segments or large networks as a whole. You can protect individual pieces of your components, individual pieces and components of your application based upon the sensitivity or the role or function of that application itself. Security groups can be a little bit difficult to draw, and so I have an extra picture that's a little more traditional that shows how you can actually control traffic and the flow of traffic within your virtual network. In this example, you have your users who connect through a security group or conceptual firewall to your load balancer. The users are only allowed to connect directly to that load balancer. The load balancer then is only allowed to talk and load balance across the web server farm. And then the web server farm is only allowed to talk to the database server. As I said before, it's a little bit difficult to draw because security groups are also referential. They're self-referential, or you can reference other security groups, which allows you to specify that a specific component, like a load balancer or a group of load balancers, are only allowed to communicate to another specific set of components, like web servers. But just because servers or instances live within the same security group does not necessarily mean that they have the right to talk to each other. So unlike traditional network infrastructures, when you put servers on the same subnet or between two physical firewalls, they have the ability to communicate with each other over the network. Security groups do not allow that unless you actually specify a rule that says a web server is allowed to talk to a web server. So in this updated diagram, it be more accurately represented as having another barrier between those web servers where the security groups, even though they're in the same group, are not actually allowed to talk to each other unless you specifically allow that traffic. In addition to security groups, as I said before, we have network access control lists, which are stateless firewall rules. Security groups are stateful. Network ACLs are stateless firewall rules that allow you to control what traffic you're going to allow in and out of a specific subnet. Because they're stateless, they are an excellent use of network access control lists is to create deny rules or to isolate specific sections of your network that you want to ensure that specific traffic does not come in and out of. So for example, you might have a security policy that says that insecure protocols like TFTP or FTP or something like that are just not going to be allowed. And so you could create a deny rule that says, I'm just not going to allow this traffic to occur on my network at all. In addition, so a third way of controlling traffic is with your routing rules, as I said before, that you can create individual route tables for each of your subnets and determine what rules you want to specify and what networks, both in and out of your virtual private cloud, you want to allow your subnets or your instances within those subnets to communicate with. So now we have a network. We've broken it up into individual components, and we've created routing rules or network control rules that control the flow of traffic in between those networks. But the next thing that we need in terms of a component are doors or gateways in and out of this network in the cloud. And so we provide a couple of those. Virtual Private Gateway is one of them. It comes in a couple of flavors. And an Internet Gateway. So starting with the Virtual Private Gateway, the first flavor is an IPsec VPN that you can create between your data center and your virtual network in the cloud. What's really, really cool about this service that AWS created is that it's completely automated. With just a couple of clicks, you can go in to a wizard and you can say, this is my hardware VPN connection in my data center, and I want to create a VPN connection between it, and then we'll spit out a configuration file that you can give to your network engineers, and they can take and implement on your hardware VPN connector or VPN device and connect into this and connect into our side of it. What's really, really cool about it is how fast you can do it. I had a customer who I was sitting down with, and we started the meeting. It was an hour-long meeting. We started the meeting. They had no idea about any of this. So I'm going to spend about 50 minutes talking about a lot of these concepts with you. And I started doing that, explaining virtual private clouds, creating networks, how you could do all these types of things. And fortunately, on the phone, we had somebody from their networking group who could actually authoritatively say, you know what, this is a block of network addresses that we've never used before, that we haven't used, we've got no plans for, so let's go ahead and use that. So after about 45 minutes of explaining kind of the concepts and the theories, I said, okay, let's just walk through the wizard. And we created a virtual private cloud, and we created a couple subnets, and we created a virtual private gateway, and it spat out a config, and the guy on the end of the phone said, this is awesome. I'm going to take this now, I'm going to create a change request, and in 3 to 4 weeks, we should probably have our connection set up and done. And I was like, okay, well, at least you're not waiting on us, right? In addition, what's cool about this connection is that we make it natively redundant for you. So as part of that configuration, we are actually configuring 2 different hardware devices on the AWS side. We're giving you 2 different tunnels that you can create, and we will automatically handle failover between those tunnels if a problem occurs. So you actually have on the AWS side a fully managed hardware VPN solution that is located in 2 different data centers that's connecting into your back-end network. Another variation of this is AWS Direct Connect. So I said a couple of minutes ago that your AWS network can be as close as a router hop away, and Direct Connect allows you to actually implement that. AWS Direct Connect allows you to provision a fiber cross-connect, either a 1 gigabit or a 10 gigabit or multiple of those, from an AWS facility to a router of yours or to a network provider of yours, and allow you to bridge your network to AWS through a router and through a physical connection. So you no longer have to worry about going over the internet or latencies potentially available to the internet. You can actually provision as much capacity as you want and basically private connections between your data center and AWS. And then you can connect that into your other data centers through your existing WAN connections, MPLS, or other types of networks. The second door, or gateway, in and out of this virtual network that you're creating in the cloud is the Internet Gateway. Now, the Internet Gateway is a little bit of a misnomer, because what it does is it provides you with a gateway or a door that allows you to interact with publicly available services. And typically, you think of that on the internet. However, there are also AWS services that are publicly available, like S3, like DynamoDB, like a lot of these other services, Glacier and things that you've heard within this conference, that live off of publicly accessible endpoints. So the Internet Gateway provides you with 2 major components or 2 major features for your virtual network. The first one is it allows you to use AWS's massive internet pipes for serving traffic to your customers. Additionally, it allows you to connect much more easily than using the virtual private gateway to other publicly accessible AWS services. Even though it's called the Internet Gateway, though, we're not just going to take traffic and send it off across the internet and then bring it back in again. It's actually on the border or the edge of our network. And so when you access publicly facing AWS services through your virtual private gateway, you're not actually leaving, or through the Internet Gateway, you're not actually leaving AWS's networks. You're just getting routed back into the other services. So it gives you a much high bandwidth connection from your virtual private cloud into the other publicly available AWS services. You also have the ability through routing rules to specify how you want traffic to flow. So you can specify that there are certain traffic or certain subnets that you want to allow to use the Internet Gateway. We call these public subnets because they're publicly facing subnets. You can also think of them as like DMZs that are allowed to use and to interact directly with the internet or directly with publicly facing services. You can also specify that there are other subnets or private subnets that you only want to interact with your back-end systems or back through your data center. So you have the ability to control how you want traffic to flow and where you want systems to talk to, depending upon which door you want your traffic or your systems to use. So now that we've got our gateways and our instances and we've got our networks, the next thing you need to do is connect to those instances. So there are a couple of different ways for connecting from your data center or from your customers to those instances. The first is you can use IP addresses. You can use private IP addresses, just like you would within your regular data center, within your regular corporate network. You can access through private addresses and through access these systems directly, going over your VPN connection or a Direct Connect connection. You also have the ability to create or map elastic IP addresses or publicly routable IP addresses that belong to Amazon to instances in your networks, in your subnets in your virtual network, that allow you to connect to outside resources or to serve content to your customers. So this is connecting to individual servers by IP address, either a publicly routable IP address or an internally routable private IP address. In addition, you can use load balancers. You can use our load balancing service, the Elastic Load Balancing, or you can use a third-party load balancer with Elastic IP addresses, but basically fronting a farm of servers that are privately accessible with a load balancer. So in this example, you've got an externally facing Elastic Load Balancer that has an external address that your customers will use and connect into, and it will farm your traffic across your instances that live within your virtual network in the cloud. You can also create a mid-tier load balancer. So if you want to address or connect to mid-tier services, whether it's web servers talking to application servers, different farms of servers, or whether you're building a separate farm of servers or a different service within your virtual private cloud, you can have mid-tier load balancers as well. And then finally, if you could create services that are internally facing completely. So you may want to create a service or an application that is accessible from your internal users only, and you could create an internal load balancer and expose that endpoint to your end users and to your customers inside, or your employees inside your own corporation, and have your systems or employees access your systems over a VPN connection as well. So in summary, that's the basic building blocks that you have. You've got a virtual private cloud, which is your major network, your overarching supernet, if you will, for the network that you're going to have in the cloud that you can break down into multiple subnets. You have multiple mechanisms for controlling how you want traffic to flow in and out of your networks. You've got different gateways, virtual private gateway or Direct Connect or the Internet Gateway for allowing traffic to flow in and out of your virtual network. And then you have multiple mechanisms through IP addresses or through load balancers for connecting into those particular instances. So now what we're going to do is start putting them together into different patterns that you might want to be able to use. And hopefully you've already started thinking about some of those patterns. So the first pattern I want to talk about, I'm affectionately calling a data center on a stick. So any networking guys out here who remember the router on a stick kind of old design pattern from several years ago? A couple nods over there, so a couple people remember that type of stuff. For those of you who don't, before you had level 3 routing or level 4 switching, you had to have 2 separate devices. You had a router that you physically connected to a switch, and then the router on a stick design pattern, you would have multiple virtual networks that you would create over that stick or that one physical connection that you had between your router and your switch. And it gave you a lot of flexibility for being able to route multiple traffic and a lot of different things over and basically kind of connect together your layer 2 and your layer 3 kind of switching and things. The virtual data center on a stick uses just a VPN connection to basically offload or allow you to extend your data center into the cloud, but it provides no internet access at all except coming through your corporate through your corporate network. So it's a very, very secure extension of your data center, extension of your network, and you get to continue to leverage your existing internet pipes, your existing policies, and systems for having traffic between it. You're probably going to want to implement additional redundancy, though, in this type of design. And so we do support connecting multiple endpoints or multiple VPN connections from different facilities if you want, or different devices if you want, into your virtual private cloud. As I said before, the virtual private gateway component of your virtual network is already redundant on the AWS side. And if you want redundancy on your side, you're welcome to create multiple VPN connections. In this example, the customer has 2 different physical data centers. They've got 2 different hardware VPN routers that they're connecting into AWS, and they're handling routing between their locations and failover and redundancy using their existing networks. One of the things that the virtual private gateway allows you to do is to exchange routing information, routing priorities with us, so that we will direct traffic based upon the rules, again, that you specify, or the routing priorities that you specify. So you could send and you could communicate to us that you want specific traffic or certain subnets within your location number 1 to receive traffic, and you want, or priority to receive traffic over directly through location number 1, and what subnets or networks exist in location number 2, and we will honor the priorities that you set, and we'll direct traffic initially to those locations and then fail over to the other location if there's a problem with the primary. If you don't want to actually control routing and failover on your side of the network, there's a feature that we have called AWS VPN Cloud Hub that allows you to actually connect multiple endpoints into a virtual private gateway and exchange routing information, and we will actually route traffic between different sites of yours if you want to. So you could create a hub and spoke model with multiple data centers using the internet as a backbone and AWS as your hub router to route traffic between different data centers without having to create point-to-point connections through all of them or leasing lines or things like that. That's a mechanism that you could use for connecting multiple data centers or multiple locations all through the cloud. So this architectural pattern is ideal for reusing your existing IT services and networks. So if you have existing networks that you've provisioned to other customers, you can reuse those existing connections. Reusing existing services like your identity and access management services or monitoring, source control systems, things like that. It's also ideal for reusing your existing internet connections to the internet. So many companies have very, very robust security controls and security policies and technologies that they've put in place to protect against data loss. So data loss protection tools, or for watching, setting up elaborate intrusion detection systems for watching traffic between their internal networks and the internet. And in this model, there's no mechanism for your cloud resources to communicate and to bypass those existing controls, because all traffic to and from the internet must go through this VPN connection and traverse your corporate network. It's also ideal for using an AWS managed VPN endpoint on our side of the connection, and for bursting into the cloud scenarios where you have autonomous sets of work that you want to run in the cloud and then report back into your existing systems. It's less ideal for our internet-facing applications, because your traffic has to completely traverse the entire network, the VPN connection as well as your corporate network, before serving traffic to your end customers. You don't have the ability to leverage AWS's internet pipes for that. It's also not ideal for accessing the non-EC2 services or the other services that are publicly facing within AWS, because in order to access those services, you're going to have to actually leave AWS's networks, traverse a VPN connection over the internet, traverse your corporate network, go out your internet pipes, come back over the internet, and connect into AWS's resources, and then have a return trip. It's also not ideal for offloading apps that are constrained by bandwidth or latency, because often these applications have latency requirements or bandwidth requirements that are greater than your internet pipes or your VPN connection pipes as well. And it's also not ideal for non-standard VPN requirements, because the hardware-based VPN option that we provide you is very, very powerful. It supports a tremendous number of different VPN hardware vendors and router vendors that can connect into it. However, if you have non-standard requirements, we haven't necessarily automated a solution to solve every kind of non-standard requirement. So there are a couple of variations that we can make to this design. The first one is fairly obvious. It's a very minor variation, that you can replace your IPsec internet-based VPN connection with Direct Connect. This allows you to provision potentially a lot more bandwidth than you might otherwise have with your internet connections. It also allows you to potentially have a much more consistent networking experience, because you're not subject to internet latencies with traffic going over the internet. Another variation is, rather than leveraging the virtual private gateway, you could leverage a software-based VPN appliance that you could run on an EC2 instance. And this would give you the ability to manage both ends of your VPN connection. You can fully manage exactly how you want the complete security policies, the patching, and everything on both ends of the connection. An example of this non-standard requirement is Xenos. So Xenos is an on-premise managed solution that allows you to helps manage and monitor systems within your on-prem environment. And they decided that they wanted to create a software as a service option that they want to extend to their customers. And so they decided that they're going to build the software as a service option in the AWS cloud. And then what they needed to do is to extend this virtual network that they created in the cloud to their customers. So the approach, and they have a non-standard VPN requirement because they have a whole slew of different customers. They have no idea what their customer networks are going to look like. They have no idea what the networking environment and what the addressing scheme is going to be on the customer side. And so they needed to provide a solution where they could ensure that they could create VPN connections that were independent of the addressing scheme, and to be able to do some network address translation between their internal networks or their cloud network and their different customer networks. So they set up an environment where they have a subnet for each customer, and then they create network ACLs that deny traffic between any of the customer networks. So every customer gets their own dedicated instances that are running software for their connection. They connect an individual VPN connection between their individual customers and their individual software as a service environment in the cloud. And then they have very strict network access control rules that forbid and make it impossible for any customer from one customer subnet to talk to another customer subnet. And then they do have a shared subnet, shared services subnet, where they process aggregate information for their customers. And then, of course, they've thought this through, as I said before, giving themselves a lot of room to grow, so that they have the ability to scale out to a number of different customers, because they have plenty of room to keep adding additional subnets and keep adding additional VPN instances based upon their needs to grow. So the second architectural pattern should look familiar to you, because we drew this picture when we were talking about the different gateways and components. But it's to create a hybrid integration between your on-premise infrastructure and AWS. So in this first example, it's using an internet VPN connection where you're leveraging an internet VPN to connect your networks between your on-prem networks and your AWS network. And you are leveraging AWS's internet pipes or internet gateway for serving traffic to your end customers. You can make a quick variation, just like we could in the previous pattern, by adding on AWS Direct Connect to this environment as well. So this is ideal for reusing existing IT services, right? So if you have existing identity and access management systems, just like with the previous pattern, if you want to connect into source control systems, or you have your different investments that you've made in license servers and things like that that you want to connect into, it's ideal for leveraging AWS's internet pipes. So being able to use our tremendous bandwidth to the internet for serving traffic to your end customers and not having to necessarily provision more traffic and more internet connectivity for your existing data centers. It's also ideal for making the most out of combining AWS with your existing systems. So augmenting systems where you need to, and connecting back into services that you might have created before, or helping you migrate systems from on-prem into AWS as well. And it's also ideal for accessing non-EC2 related services or the other AWS publicly facing services, because you can use the internet gateway and connect much more effectively to your systems and to your and to the other publicly facing AWS services through the internet gateway, and not having to traverse your VPN connection and your entire corporate network and back and forth. I don't know if anybody's tired yet of hearing about NASA JPL. We love talking about them. So hopefully you're not too tired about hearing about them yet. Their whole scenario makes me so excited. Whenever I hear a new story, I like to run home and tell my 10-year-old son, who really loves astronauts and space and astronomy, and it's just really fun to tell him different stories. So they are a great example of this hybrid integration, of leveraging their existing resources and things within the environment. So NASA JPL leverages their on-prem infrastructure for license servers, for their information security management systems that they have in place. They also connect into their deep space network. So they've got a couple of different networks that they actually are air-gapped from many other systems for obvious reasons, like the deep space network or the radar network that they have for connecting into radar. And so they use those systems for talking to Mars, talking to Curiosity, pulling down information and things like that, very proprietary systems for managing rockets and things like that, to pull in that information. And then they ship that information to AWS, and then they leverage a whole slew of AWS services for being able to process all that information, including using our internet pipes for delivering that information to the world, and our content delivery network and things like that. So they're really leveraging and augmenting a lot of their existing things and existing systems, and expanding and extending kind of both ways, both their existing systems into the cloud and then the cloud back to their existing systems for processing the data for mission control and things like that. So this architectural pattern, though, is not ideal for everything. It's less ideal for data center consolidation or data center cost reduction type scenarios, because you still have to continue to maintain and manage your existing data centers, right? You still have to provide power and cooling and all the different things within your existing data centers. It can definitely help with some cost reduction activities as you migrate systems over and if you can shut other things off, but it doesn't necessarily help you with completely reducing those costs or eliminating different data centers, because you're continuing to leverage kind of both of them. So for customers that really want to move their entire data centers out of the way, there may still be a need to create multiple networks within the cloud. You may want to do that for geographical regions. You might want to have a virtual network on one side of the world, and or on one side of the U.S. and another virtual network on the other side of the U.S. for disaster recovery purposes, but you still want to connect those networks together. You may want to have different networks for different customers. You may have different networks for different needs within your business. So you might have a test and development network that you want to have different security requirements around than a production network. And so you may want to create multiple of these virtual private clouds, these VPCs within AWS, and connect them together. So the first and most straightforward way of connecting them together is to leverage AWS Direct Connect, where you can logically associate multiple virtual networks to a Direct Connect router, and then you can manage routing traffic between the different virtual PC, between the different networks, virtual networks within AWS, within a specific region. It's the most straightforward, but it still requires you to manage the hardware router that is controlling the Direct Connect situation. So if you want to completely get out of the hardware business, you can connect multiple ways between different VPCs. In this example, you can take a software VPN appliance in one VPC and connect it into a hardware VPN virtual private gateway in another VPC. The advantage of this approach is that at least on one side you have hard redundancy that's already built on your behalf, and you don't need to worry about failover and things like that. On the right-hand side, though, you still do need to worry about how you're providing a second software VPN appliance or how you're going to handle failover in that type of scenario. But it does allow you to connect your multiple virtual networks into a consolidated network into one larger consolidated network. An example of this is some plans that we have with Xenos for their software as a service example, is for them to be able to expand into multiple regions to support different customers, to be able to provide different environments for their customers in different regions that are closer to their customers, and also to provide disaster recovery type solutions. And because they're already building out their own customized VPN solution for connecting between their customers and their software as a service option, it makes the most sense for them to continue to leverage that to use two software VPN appliances on either side and connect together so that they're continuing to manage and update the entire solution as a whole. Fourth architectural pattern is a remote access pattern. So a lot of companies are being pushed, as we said before, in many different ways. And one of the ways that we're being pushed a lot is remote access. So at first look, many companies say, well, I already have a remote access solution. I already have a VPN connection that I use for my employees that's already set up. And you absolutely can continue to use that with one of the other patterns where your employees can log into your VPN solutions into your corporate networks and then can connect over a VPN connection or over a hardware-based, or over a Direct Connect connection to connect from your corporate network into your AWS cloud. However, we're starting to get lots and lots of additional remote access questions. One of the cool things about the virtual private cloud is that you have the ability to bring your own network, and that's very, very similar to the concept that a lot of us, I think, have, or the reason that I picked kind of that term, is the bring your own device challenge that a lot of us have, right? So there are a lot of companies that are now starting to struggle with, how do I deal with bringing my employees who want to bring their own devices that I don't have the ability to control, to set necessarily security policies on, and I want to treat these devices as a different class of thing, right? I want to have a different infrastructure. I don't want to just suddenly take these infrastructure components or take these devices that the employees are bringing and treat them just like a corporate laptop that I might issue to a customer. And so you could set up a remote access server within your virtual private cloud, and you could specify a special bring your own device access points or gateways that you could create for them within the cloud without having to worry about without having to build out a whole bunch of additional infrastructure inside your existing network. An example of this is a customer that I have who has a lot of different mobile devices. It's actually a remote utility monitoring customer. If you think of different utilities like your power meter and your gas meter, and they've got a bunch of different devices that they need to collect data from. These devices are all over the place, and so the first thing that they needed to do was create a mobile network that would allow these devices to connect into and talk to each other and to bring data in. And so they contracted with one of the major telco companies to create a completely private 3G network that is only accessible by their devices and is private to their particular just to their devices. They then said, okay, well, now that I've got all my devices connected, I need to have some place to store all this data, and I need to be able to process all this data, and they didn't want to go out and create and build a data center or colo. So they decided they would use AWS, and they built a virtual private cloud in AWS. And then they created a hardware-based connection between their AWS virtual network and their telco's network, creating a completely closed private network that extended from a private 3G network extending into AWS, where they could bring in all of the data that they needed, and they could process all the data and report on the data that they needed to do within that solution. Additionally, AWS has had this challenge. So we're here at reInvent, and I'm sure that it come to no surprise that a lot of AWS employees have come to help support this event. And AWS wanted to provide a secure wireless network to allow the employees to access and to do their work when they're not helping out with different aspects of the conference. In fact, and also, we didn't want our employees to bog down the wireless network and give the attendees a wireless network a bad user experience, because suddenly we've got a lot of employees who are building it. So we basically had a remote access problem where we have a number of different remote employees, or a bunch of people here, and we didn't want to build a huge infrastructure for it, because at the end of the week, we don't have that problem anymore. We don't need to support that anymore. So we created a virtual private cloud that is running a product from Sophos called the Universal Traffic Manager that actually extends and connects from the virtual private cloud into physical access points that are also from Sophos that we have in some of the back rooms, and we create a secure network and a secure tunnel. That also allows us to push policies that we specify inside of our VPC out to the end devices to provide different wireless access protection to our end users and intrusion detection type capabilities to those different resources. And so that's allowed us to very, very quickly and very, very cost effectively stand up this environment. Not only did we stand up an environment to do this, but we were planning for failure. And we actually built the solution so that it's running in multiple availability zones, and in less than 5 minutes can fail over from one availability zone to another should there be a problem with one of the servers or one of the remote access solutions. So no architectural discussion would be complete without discussing an anti-pattern. So the one question that I get the most from customers is, what's the single most or worst thing that I could do to negate all of this? What's the worst thing that I can do that I can, we've set up our connections, we've done everything, what's the worst thing that I can do? And typically, it's taking a big traditional firewall and sticking it right in the middle of the entire scenario. So don't get me wrong, I don't hate firewalls. I think they're great. They were really, really great back in the late 90s. They're big and expensive. No, so there are reasons that you have firewalls in place, right? And typically, it's because you want to, you trust the technology because it's been worked and it's been successful in the past. You want to control traffic. You want to verify because you can do logging. You want to make sure that you know what's going on. But they typically introduce these really, really long change management processes into your overall infrastructure. Typically, you have a 4 to 5 business day turnaround for firewall requests. I recently had a customer, not the first one that I talked about, but another customer who said that they really need to get a change in quickly because if it wasn't done in this 5-day period, they'd have to wait a month because it was a retail customer. And with Black Friday and Cyber Monday going into effect, they had a complete freeze, no firewall changes and things like that could be made. So what you really want to do is be careful about implementing that. So the compromise that tends to work very well for customers is to implement that. If you are going to implement a firewall, because many companies have policies that say you should do it, there are a number of things that you can do to protect yourself while still allowing you to not completely stifle the innovation and the capabilities that you would be getting from the AWS cloud. The first thing is that you really should make sure that you test and you come to trust that security groups and network ACLs and routing rules actually work. So we definitely recommend that you test it, that you do different things to make sure that those are working, and come to rely on and to trust that your security groups and the security group rules are actually going to implement and control traffic the way that we say that they're going to do. However, that's trusting it, but you still want to make sure that you control traffic. So one way you control traffic is, again, use security groups, use network ACLs, use your routing rules to make sure that you're controlling the flow of traffic within your network and between your virtual network in the cloud and your on-premise networks. But you can also verify it. Go ahead and put a firewall in and monitor the traffic and verify that all the rules that you've put in place are actually the rules that are going on. So typically my recommendation is that you could have a firewall that has very hard boundaries, that denies traffic that's outside the realm of what should exist. Right? So there's no reason that any network traffic should traverse that VPN connection that does not exist, that does not belong in your virtual network, that exists from outside the virtual network, or doesn't belong within your internal network. Right? So you could have hard rules on the outside saying, I'm not going to allow any networks that don't exist on one side or the other to talk to each other. And then you can log those and make sure that, indeed, no traffic that you didn't think belonged was actually even attempting to go over that connection. But then you can also monitor the traffic that is between the networks that you're expecting to make sure that it's behaving the way you expect it to. Additionally, we've got customers who say, OK, well, but what about the security group rules? I might have developers who are creating these rules. How do I make sure they're not implementing poor rules? Well, one of the things that we have as part of our Trusted Advisor option, which is part of our premium support if you are a business support or an enterprise support customer, is a Trusted Advisor report that will check your infrastructure and your deployment within AWS against a long list of well-known best practices. And one of the sections of that report will check your security group rules for well-known bad configurations. Things like, I want to allow the entire world to RDP into my Windows server. Right? So there are some very high-level things that we will actually provide reports that we recommend you bring into your security processes, into your security management processes, and review those reports regularly to see if that's being open. But not only that, the entire infrastructure is an API that you can create your own calls. You can define what policies you want to have, and then you can execute scripts that go and interrogate that infrastructure and tell you whether or not you have any security group rules or network ACLs that fall outside of your policies. And you can run those reports as often as you'd like, and you can compare the differences and make sure that you're continuing to do that. So you can actually implement a much stronger controlled environment that you can trust a lot more, that's a lot more controlled, and that you also have the ability to verify through many different mechanisms than you might have had otherwise. So those are the major patterns that we talked about: the virtual data center on a stick, having a hybrid integration between your on-prem environment and AWS, integrating between multiple VPCs if you have a need to do that, and also looking at how you might leverage VPC to create mobile or remote access solutions to support different mobile requirements that you might have in addition, or where you might be getting pushed as well. In terms of related content, there are previous breakout sessions that have already occurred. They have all been recorded, so you're welcome to go back. If you didn't catch them already, you can replay them. The media ingest and storage solutions within AWS, and the best EC2 features that you never knew about. Tomorrow, there are a number of additional sessions, including packet plumbing in the AWS VPC, learning from the masters, and virtual networking in the cloud, where I'm actually going to be coming back and demoing some of the features, the virtual networking features that exist within VPC with the product manager, Eric Schultz, of the VPC platform itself. You can also catch me later in the lounge for additional questions, especially if you want to get really geek out on different networking things. I love networking, so I'd be happy to talk more about that if you're interested. And then in terms of resources and next steps, the VPC product page, if you go to aws.amazon.com/VPC, you can get a lot more information about the VPC offering, as well as we've created a AWS VPC connectivity options white paper that describes a lot of these different options and even gives you links to technical briefs that will help you with configurations for setting up software VPN instances or implementing a lot of these different concepts that we talked about today. So thank you very much. We really do appreciate your feedback, so please do fill out the evaluation form.